we, I begin to talk about surface tension. That is the last part of uh, fluid statics, right? Surface tension, like I mentioned, if you look at the uh, pictures or on this slide, you see that they are all phenomena that related to surface tension of liquids. One good example you see here, there is a clip. This is a clip, right? That can be floating on a water surface. Of course, you know that this clip is made of kind of metal, and this metal should have a larger density than the water. So basically, if you put this clip submerged into water, it cannot be floating at all, right? Because the buoyant force is not enough to make it floating. This is one example of surface tension. Means that this metallic clip is floating on water surface. It still not really break the surface of the water. And another example is this picture. You see that a drop of water is formed on a curved surface. And as I mentioned already, that you might be familiar with this picture before because you did some experiments in the science class when we did this online, right? And well, how the drop of water from the form or on the surface really depending on the property of the surface that related to two important two important type of force. One is cohesive force and the other is adhesive force. Both of them are attractive force between molecules. Cohesive force is an attractive force between the same type of molecules, like water molecules on the surface of the water. And this is the source of, and this cohesive force is the source of surface tension. Surface tension force that pack the molecules of water on the surface. If the weight, look at this picture of video clip. Sorry, not video clip. Look at this picture of a metallic clip that can be floating on the water surface. If the weight of this metallic clip is not large enough to break the bonding between the water molecules on the surface, means that the packing between the water molecules is larger than, is stronger than the weight of the metallic clip, and the metallic clip can be floating on the water surface, right? Adhesive force is the attractive force that form between different type of molecules. In this case, if you consider a drop of water on the surface, the force that pack the molecules of water on the surface of this drop we call cohesive, right? Cohesive force. But the force that attract the water molecules and the molecules of the surface we call adhesive force. And these two forces are competing each other. And this tells you how the drop of water form on the surface. Of course, this depends on the properties of the surface. And you might be familiar with, this is called hydrophobic. Oh, I don't need to write down here. This is hydrophobic. Large hydrophobicity can make the drop of water more circular. I should say more spherical, right? Because hydrophobic means that the molecules of the surface do not like to attract with the molecules of water. So it tend, so the water tend to be in contact to the surface as small as possible. Tend to be contact with the surface as possible, right? Because, and in this case, the cohesion between water molecules dominate. The addition between, I should say this, cohesion between water molecules dominate. The addition between the water molecules and the surface molecules, right? And the water molecules tend to pack, to be close to each other and stay away from the surface. Oppositely, if what is hydrophobicity? This should be small. This should be large. Hydrophilic, sorry. I'm wrong. It's already called hydrophilic. Alright. Alright. Okay. I should not write here. Okay, let's say this is hydrophobic. I had a mistake. Okay, alright. This is called hydrophilic or hydrophilicity. Means that like water. This one it should say it hates water, right? Like water means that the water molecules like to pack with this surface molecules than the water molecules themselves. So the drop water try to expand, expand to increase the contact area. And in this case, of course, it's try to expand because it love each other. They love each other. I mean, water molecules and the surface molecules love each other and like to be in touch. Addition between water molecules and the surface molecules prefer to pack together. And the addition in this case dominate the cohesion. All right. And if I'm not wrong, when you did the experiment in the sinus class, you also try to measure the angle between the surface and the drop of water and try to compare, right? You try to change the properties of the liquid. I mean, you add something into the water and you get less hydrophobic water, let's say. Because water is really actually, well, it's water, right? It's really polar. And when you add something in, make it a solution, the polarity of the water can be reduced, and that make it love the surface more. Also, when you change the surface and you keep pure water as a control variable, and you change the properties, the surface property, you will get also the different formation of the drop of water, right? That's what you have done in the sinus class. Okay, I shouldn't talk a lot. We doing this online. It might make you confused. I will try to speak less, let's say, and write more. Okay, so for the surface tension force, let's say, of course, there should be a force because we talked about force before, right? Uh, cohesive force. We talked about cohesive force before, and this force related to a property of that liquid. Okay, should begin like this. Let's say, when you see, because we talk about adhesive force and cohesive force, and you might be confused later how different between them are in nature. You know that cohesive force is a force that pack the same type of molecules together, like I mentioned, and adhesive force is a force that pack between different type of molecules, like water and the surface, or water and glass. When you put water in a glass container, for example, they have very similar what to say description in terms of mathematical equation, let's say. Okay, so now think about when you put, so go back to the case of the metallic clip that floating on water surface. So let's think about this case, right? When you put this metallic clip on the water surface, there is a force that go against its weight, or let's say go against the gravity that try to pull it down. And when, okay, so let's make it simple. So this is like a wire, metallic wire that floating on water. So this water. Oh, I should not write this. Okay, let's say this is floating on water. There should be a force that done by okay, excuse me, I need to receive a phone call. ฮัลโหลสวัสดีครับโอเคครับผม Alright, sorry. Okay, that should be the force that go against the weight mg. Right? And this is the force that done by the surface. It's a reaction force that done that push the object up against the gravity, and this force is done by the surface tension force, and we call this surface tension force. And this F is the surface tension. This is the surface tension. That is the property of liquid. That is the property of liquid. Multiplied by the L. That is the contact length. And in this case, because the object is still on the surface of liquid, there is no buoyant force, still not there is no buoyant force taken into account because the object is still floating on the water surface, not getting submerged into the water, right? Okay, so let's say the contact length. So when you treat with this surface tension force, we don't care about the contact area, but we care about the contact length actually. Okay, so shouldn't have this here, but anyway, you see that if I write that wire, I'm trying to zoom in a bit, and and we look from the cross-sectional, this is a cross-sectional view. We look at the cross-sectional view, and we see that there should be a force that hold the object up, right? Like that is the surface tension force, as I mentioned, and this is mg. For the case of wire with a length L, so let's say this is a wire with the length L, right? Length L. The contact length okay, so this contact length is 2. Sorry, should be the same L here. Okay, small L. The contact length has what to say, we need to count 2 sides of the wire, because both sides of the wire, this side and this side, we call it left and right, are both in contact with the water, right? And the total L is L plus L or 2L. For a case of ring, let's say thin ring, right? Thin means that's the inner, what to say, the thickness of the ring is very, very, very small compared to the inner and outer radius of the ring. So this is wire, this thin ring with radius. Oh, my handwriting is bad. Thin ring. L is 2 pi r plus 2 pi r, and because we approximate that the inner radius and the outer radius are the same. Okay, I should write this first. In, out. But because we assume that R in is about R out, so you get L equal to 2 multiplied by 2 pi R. This you know is a plate. It's a circular plate, right? And it's a circular plate, and the contact only the contact between the plate and the water surface, the liquid surface, let's say, only at the edge, happen only at the edge of the plate. So you can say this is 2 pi r only. And the force, and you can you know the geometry of the object, and you put the L in, and you know the force that balance the mg, and that make the the object floating on the liquid surface. And if you notice from here, the magnitude of the force F what you say is the equation F equal to gamma L here seem constant, right? With the object with the constant geometry. Because gamma, like I mentioned, is the properties of the liquid. So this is called surface tension, and it has a unit of Newton per meter. This is surface tension. And different between the type of liquid. You see that water has a surface tension is of about 0.07. And soapy water, if you put the soap in, it's decreased. And also ethanol has very much smaller surface tension. For example, it really depends on the type of liquid, and also the temperature. If you notice here, upon going up in temperature, you will see the surface tension is less. That because at higher temperature, the liquid molecules has more kinetic energy and trying to stay away from each other, trying to move and stay away from each other. That's the reason why at higher temperature, you get less surface tension. What's it? Sorry, this is annoying. You teach and so many things pop up. All right, I come back to this equation. What I mean to say is, you might notice that, this should be a constant. But again, no, what is this? Okay, and again, if F equal to gamma L is constant, means that, what does it mean? And when and when you put the object that made of different material, and they have the same geometry and the same but different density, so they have different mg, right? Can you follow me? Let's talk about this. When you have, let's say, an object with the same geometry, so so I have, let's say, gold and iron wire. I don't know which one has my handwriting. I don't know which one has higher density, but if they have the same geometry and size, they should not have the same weight, right? They should have different mg. Absolutely, because they have different density, right? And why I say that, when you put the object on the surface of liquid, F equal to mg, the force is balanced with weight mg. Actually, it means that this force that equal to gamma L and seem to be constant here is the maximum force. That break, that can make that okay, let's say, I shouldn't say that. It's the maximum force, means that this is the maximum force that the surface can't stand for. The larger than gamma L, the object will just submerge down. F that equal to gamma L is the maximum force. That's what I mean to say. Because in fact, when you put an object with different weight on the surface, what you will observe is the change of the surface of liquid. The change make it from flat surface to kind of right is better. Okay, the change make it from flat surface to something like this. So the surface is now not flat anymore. Right, and the direction of force act on both sides. We will call this is F palm. We have F palm. Okay, right. We have F palm, and you know that the angle now, this F palm is tangent to the tangential between the surface of water or of liquid. Let's say surface of liquid and the surface of the object at the contact point. Now you see that, and we treat this as angle theta. Now, so let's forget about this equation and try to see the balance between the force, the reaction force that the liquid act on the object. So you can find the net force by split the component of this F palm, right, into the vertical direction, and this force should actually balance with the weight of the object mg, and this force is the force that holding the object on the water on the liquid surface. And we can write down these two F palm psi theta equal to mg. And larger m lead to the larger theta. And this F palm, we can move, rearrange the equation and say this F palm equal to 2 mg divided by 2 psi theta. Don't forget this F palm is the force that act on each contact length. So if the object has is a wire with the length L, and the maximum force on each side, that act on each side of the object is gamma L, right? I should say, okay, I will change this L to small l, let's say. And you know that the total force that act on really act on the object is 2F, or gamma multiplied by 2L, that like I mentioned before for the case of wire. But you know that F, this is the force that act on each side, right? And okay, for the case that the object has a weight of mg, this is still not maximum, right? You know that what to say, this F palm will be always less than gamma L, and the maximum of F palm can be only equal to the gamma L. That is the maximum force that the surface tension force can hold the object on.